So students, now you can see the problem states that a line CD 60 mm long, this is the true length of the line, right, has its end C in HP and 15 mm behind VP. When the line is behind VP, that means it is either, the point is either in second quadrant or the third quadrant. Okay, but it is also in HP, that means that the point is lying on XY line. One part of the point is lying on XY line, that is the front view, right? Front view lying on XY line, so C dash will be on XY line. The end D is in the first quadrant. Okay, so front view above XY and top view below XY. The line is inclined at 35 degrees to HP and 55 degrees to the VP. Draw projections of the line. So that's the problem. Now we will be drawing this problem properly. So now I have drawn this XY line, which is an horizontal line. Now I will be drawing one vertical line towards the X side. Okay, I have drawn this particular line. I will call this line as an end projector of C. End projector of C, EPC. Okay. Now the important part is that point C lies on XY line because it is lying on HP, but it is 50 mm behind VP. So anything which is behind VP always comes above XY line. Okay, so this particular point on XY and on the EPC is my C dash, and from C dash I have to measure 1.5 centimeters or 15 mm. So like somewhere like here, this is my point C. So I will be drawing another line passing through this point C, and that will be the locus of point C. And this is the locus of C dash. This is point C dash. This is point C. Now they have given that the true length of the line is 60 mm. However, they have also mentioned that the 35 mm is the angle with HP and 55 mm is the angle with VP, and point D is in the first quadrant. So that means D dash will be above XY and D will be below XY. For this, we need to draw angles very carefully. The angle with HP will be from C dash point. So I will be taking my protractor, and now I will be measuring 35 degrees angle. It will be over here, and from C I will be measuring 55 degrees angle downwards. So 55 degrees over here. Now I need to connect these 2 points. Okay, so this is one, and over here is another. Now since we don't have the proper location of D dash, this is 35 degrees and this one is 55 degrees. Okay, we don't have a proper location of D dash. We need to take a distance equal to 60 mm, which is the true length. For that I'll be using my scale and a rounder. It will be over here, the point, and then the 60 mm. Okay, so a little bit more. Yeah. So I have a distance of 60 mm in my rounder. I'll be placing it on C dash, and I'll be cutting this line over here. Similarly, I'll be taking the distance of 60 mm from C, and I'll be cutting another line, another cut on this 55 degree line. Now I have to draw 2 lines passing horizontally, passing through these 2 points. Okay, so the above one is called as locus of D dash, and the below one is called as locus of D. Now this point is D1 and this point is D2. We know that we have to project this D1 point on the locus of C to get point. So this point, sorry, the point name is D1 dash and this point is D1, and if I darken this particular line, CD1, this will be my PL. Okay, similarly I have to also project this point D2 on the locus of C dash, something like this. This point will be D2 dash, whereas length CD2 dash will be my EL. Now we know that we can get true length by rotating PL on the locus of D. And we can get front view FV by rotating EL. Now if you can see carefully, this front view, that is C dash D dash, is a vertical line. This is C dash D dash, whereas the top view CD is also a vertical line, and the problem is over. Can you see why this particular thing happened, that after rotating EL and after rotating PL, we are getting all the points C dash, D dash, C and D on a straight vertical line? If you observe carefully, the angles are 55 degree and 35 degree. That means when you have theta plus 5 is equal to 90 degrees, 35 plus 55 is equal to 90 degrees, right? This kind of situation will happen where front view and top view, they will be collinear. They will be on the same vertical line. Now students, that's it. This is the end of the problem. Okay, because this EPC is also my EPD, that is end projector of D. There is a zero distance between EPC and EPD. They are one and the same. This is the special case. I want you all to remember this case because this is a favorite type of question in the exam.